Hey everybody, this is Larry. This is day 8 of the Leetcode Daily Challenge. We'll have a weekly premium afterwards as well. Hit the like button, hit the subscribe button, join me on Discord. Let me know what you think about today's problem, 1458. Max dot product of two subsequences. Okay, so return the max dot product. Okay, what is the dot product again? Without disturbing the relative. Oh, yeah. So basically, it's a subsequence. Okay, yeah. Okay. Yeah, I mean, I think there are a couple of ways you can think about this. I mean, given that the two ends are 500, so you can definitely do an n square thing. Basically, just take a no tick, right? For each side, you have to take. I guess you don't have to. You could always skip, but I guess there's only 4 possibilities, maybe. Yeah, or something like that. You could. I mean, they're not even distinct cases. But yeah, I think dynamic programming is basically the idea. Because you have to keep them in order, and you have to just either use and don't use, right? So yeah. So now let's just do n1 is equal to the length of nums1, n2 is equal to the length of nums2, right? And then now we just do was it get max? Was it? Yeah, get max. And then now we have index 1, index 2. Today I'm a little bit lazy. I'm not going to go over all the dynamic programming stuff that sometimes I go over. But just know that, index 1 represents the subproblem that defines the suffix of the array of nums1, and same thing for index 2, right? So then now if index 1 is equal to n1, or index 2 is equal to n2, that means that we're done because you need both. You need at least one element from both, so return 0. And dot product, so the reason, I think I skipped ahead a little bit. Did I say, yeah, hit the like button, hit the subscribe button, I guess. Maybe I didn't say that. But the reason why the dot product is interesting is that, it is the sum of the product of the indexes, but that means that because it's a sum, everything could be linearly greedy in that sort of way. So yeah. So then now, basically, now you could do a couple of ways you can think about it. So you can either you can skip. So let's say best is equal to I would say negative infinity just in case, right? And then now you can either just take both of them. So then right. Get max of index 1 plus 1, index 2 plus 2. Oh, sorry, plus 1. Easy to say. But this plus, so that's the subproblem. And then now just taking the index num sub 1, index 1 times num sub 2, index 2, right? So that's one way to do it. The other way is also just skipping one of these, right? And there are 2 ways to skip one of these. I think that's really it, right? Am I thinking of someone else? I mean, you could skip both, but these 2 in combination will skip both in some way. So I think we don't have to worry about it. So I think this is the only way where we take, and this is the 2 ways that we can skip. I think we're done. So then now, right? And of course we have to do memorization. I know, but let's kind of give it a quick run. Oh, you have to take stuff. Okay, fine. Wait. Oh yeah. Do we have to take? Oh, non-empty. Okay. So we have to make some modification. How do we want to do it? If we used it, or we could do. There's probably a way to yeah, because we have to do a non-empty, because if we could do empty, then this 0 will be negative. Way. We can't just do negative infinity because you can kind of see why. Yeah, it would just be negative infinity plus 5 or something, or whatever it is. So can't do that. But I think there are a couple of ways you can do it. You can maybe just brute force at least one answer. But I think you can also I'm just going to do it lazy today, and you can just do like maybe a used thing, right? So force, right? So here we just say used. If this is the case, if used, then we can return 0. That means we have at least one thing. Else, you can also do this in a number of ways. Otherwise, you return Are we maximizing the negative infinity because you haven't used any numbers yet? And then here, once we use the number, we can say true, and the other ones we just kind of keep the same use status, and that should be good. But yeah, maybe there's another way to do it. I mean, there are definitely many ways to do it. You can also just run this. I don't know, maybe this is the simplest now. But yeah, after that, then of course we ask yourself, we have to memorize. Let's memorize. So yeah, has cache the same way that I usually write it. There's actually 3 dimensions right now. Times 2. Yeah, for can type. Right, something like that, and then now actual cache itself. Yeah, so now it has cache of index 1, index 2, and then like interviews or something, then return cache index 1, index 2, interviews, right? And then of course we have to cache it later. Maybe I should have just made it 0 and 1, but I don't know, it's fine. Right, and that's pretty much it. Give it a quick submit. Hopefully I didn't make any silly typos or anything. And yeah, 1286-day streak. A little bit faster than last time. But yeah, in terms of running time, I don't know how much I saw last time. But yeah, what's the complexity here, right? So the complexity we can kind of see, right? Index 1 goes from 0 to, oh yeah, so the total complexity, total time complexity is equal to the number of inputs times the time used per input, right? So index 1 goes from 0 to n1, index 2 goes from 0 to n2, and well, use is just true or false, so true false, right? So that means that this is going to be O of 1 times n2, O of n1 times n2. 2 is equal to the number of inputs, and O of 1 is equal to time per input, because we only do VLOOKUP things or whatever. So it's going to be O of n1 times n2 time, and also space, right? Because space is the same thing, because there's also O of 1 per space. Yeah, that's pretty much all I have with this one. Let me know what you think. Let me know if you have a question. I don't think there's an optimization for this one, or maybe there's a minor thing we've used. Apparently, maybe there is a greedy solution. I don't know, but that's the DP solution, because it is really slow actually compared to how other people do it. Maybe there's a greedy way to do it. I don't know. You have to take at least one. I don't know. How did I do it last time? It was faster than last time. I guess the last time I did it actually exactly the same. Yeah, I don't know why this is faster, But I guess I didn't use IOU cache. But yeah, some people ask me also why I don't use like cache and stuff like that, and well, as you can see, it is much faster. Don't know. Maybe there's a greedy solution. Let's take a look. Oh yeah. I guess the other time is that you can also do bottoms up as well. And if you do bottoms up, there's also a space optimization. So I guess that's how you get a faster time. But 5% is pretty slow, so I don't know. It's okay. That's all I have with this one. Let me know what you think. And yeah, stay good, stay healthy, take your mental health. I'll see y'all later and take care. Bye-bye.